Okay, so for my 100% virtual students and for anybody that did not have their in-person day this week, I'm going to do 2 examples. These are from page 103 in the textbook, and I also will give you annotations for number 4, but I'm not going to take the time to go over that right now. Okay, so for number 15, we have a cubic polynomial. It's less than or equal to 8. So the first thing that we're going to have to do is subtract 8 from both sides. So that now I'm comparing my polynomial to 0. So if we notice 4 terms, we're going to have to factor by grouping here. So a squared, and I'm left with a plus 2. I can factor out a negative 4, leaving me with a plus 2 as well. Now remember with the zeros, we can disregard the inequality. So I have a plus 2 times a squared minus 4. Now in school, I did prompt everybody to factor that further. Okay, so using my difference of perfect squares, I get a plus 2 times a minus 2. And now I can see that this a plus 2 is being squared. Okay, that'll help us when we go to plug in for our number line. It tells us if we were graphing that it was a bounce point. So now for my zeros, I have negative 2 and positive 2. All right, so those are the 2 values that we'll put on the number line. All right, so now my test values, I'm going to test x is equal to negative 3, x is equal to 0, and x is equal to positive 3. Okay, so when we test, we can come back and plug it into this factored form. All right, so if I plug in negative 3, hopefully you're seeing with this first factor, if I square any number, it'll always be positive. So that'll be a positive. Negative 3 minus 2 is negative, so it'll make the whole interval negative. When I plug in 0, I get a positive times a negative again, keeping the fact that the interval is 0. Is a negative. And then when I plug in 3, I would get a positive times a positive, making the entire answer positive. Okay, so I mentioned this in the last video. I mentioned it again in class, right? The less than or equal to. So to actually write my conclusion, I have to go back to the original inequality. If I'm less than or equal to, I'm looking for my intervals that are negative. Okay. Another piece that we discussed, since I can equal 0, if I'm thinking, and I did this in the video as well, the second video, I'm allowed to equal negative 2 and positive 2, okay? Because that's what the original says. So in class, the conclusion that a lot of students came up with was negative infinity to negative 2, hard bracket, and the union with negative 2 to positive 2. Although that's not incorrect, if we were to graph the solution set, it would actually be all values less than or equal to 2. So we talked about negative infinity to positive 2. This is, if it were multiple choice, this is the answer that you would see, okay, the one that I have boxed there. This is correct, and I would give you full credit as long as the brackets are the hard brackets and not the parentheses. But we discussed, understanding why those 2 things are equivalent. All right, and then our next example, we did number 25. So for some, it was the first time you were seeing a rational inequality. For others, it was the second practice. So remember, when I have a rational expression, I have domain restrictions. So I got to start there. So when I'm looking at a rational function, I know that my denominator cannot equal 0. Okay, so my domain restrictions come from my 2 factors in the denominator. So x can equal 5 and x can equal 6. Okay, so we'll have to plot those on the number line also. Next, we determined our zeros. And your zeros come from when your numerator is equal to 0 right? Because 0 divided by any number is 0. So again, in factored form, we like factored form because it takes out a lot of the work for us. So our zeros are 3 and 4, our restrictions are 5 and 6. Now when I go back to my original, I'm again looking for less than or equal to intervals. So I'm going to be looking for my negative intervals. I can equal my zeros, but I cannot equal my restrictions. So let's throw those on the number line. 3, 4, 5, and 6. 3 and 4 are zeros. I can equal them. 5 and 6 are restrictions. I cannot equal those values. So if 5 or 6 are included in an interval of answers, we have to make sure we actually exclude it when we write our final solution. All right, now testing. So let's test 0. Notice that you have 4 x's, right? So in my original, there's an x here, 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 and here. But let's look at your last factor. You're squaring whatever the input is. So no matter what the input is, that'll always give us a positive output. Okay, so when I take 0 and I plug it in, top left, I get a negative times a negative times a negative, and then my last one will always be positive. So that'll give me a positive over a negative, making my whole interval negative. If I plug in 3.5, I would get a positive times a negative over a negative times a positive. So a negative divided by a negative would make that interval positive. 4.5, I would have a positive times a positive over a negative times a positive, right? That one always remains positive. So positive over a negative, that would make that interval negative. If I plug in 5.5, positive, 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 positive. So that would make my entire answer positive. And lastly, if I plugged in 7, again, everything would be positive. All right, so now when we actually have to look at our conclusion, create our conclusion here, less than or equal to, so now I'm looking at my negative intervals only. So I have 2 negative intervals there. And when I go to write my answer, let's work left to right. So my conclusion, negative infinity to positive 3. Positive 3 gets a hard bracket. It's a 0. I'm allowed to equal 3. Now, where's the next interval start that makes the outputs negative? It starts at 4. I can include 4 because it's a 0. The interval ends at 5, and I have to exclude 5 because it was a domain restriction. Okay, so remember, as you're writing these, you can really think of it as moving left to right. As soon as you start, where do I end? Is it a 0? Is it a domain restriction? So that determines the brackets. Okay, then the last thing we did is I just kept all the work the same, but now we said, all right, let's change the inequality to a greater than or equal to. And how would that change our answers, our conclusion? Negative, positive, negative, positive, positive, and these had open circles. So again, this was just for practice sake. So if I just change the direction of the inequality, but all my other work stayed the same, now where are all my intervals positive? So using that same, let's work left to right. My first interval starts at 3 and it ends at 4. I can include both of them because they're zeros. My next interval starts at 5 and ends at 6, but I have to give them soft brackets because they were domain restrictions. I can't actually equal 5 or 6. And then the union of that from 6 to infinity. Again, excluding 6 because it was a domain restriction. So those 3 intervals all have to be represented separately. Okay, message me if you need any help with these.